Alright, so number 91 is kind of like the polynomial inequalities before, but this one's rational. So remember, we want to basically set the numerator equal to 0 and set the denominator equal to 0 because those are points where the function can change from being positive to negative. So if we set the numerator equal to 0, 15 minus 3x equals 0, that happens when x is 5. We'll see. Alright, so remember, the reason we do that is because at x equals 5, this function, a function can be something like this. So right here at 5, it's either going to go from being positive to negative, but it's going to go through 0, or it could go from being negative to positive, and we don't know. We're going to figure that part out, but 5 is a point where it may cross. Alright, so likewise, let's go find when the denominator is equal to 0, because when the denominator is equal to 0, it's a more complicated thing, and that's going to occur at negative 1/6. I can see over there, so it'll be over here. What happens here is we have what we call a vertical asymptote, and the function is either going to do something like this, most likely, or it may go the other way. It may go up here and then come in from down here. So anyway, at where the denominator is equal to 0, it can also change from being positive to negative. So the denominator equal to 0, put 6x plus 1 equals 0, and we get negative 1/6. Alright, so remember, now we set up our number line. That's how we're going to do this. And so I always put 0 just for a reference point. Alright, so negative 1/6 is just right here to the left of 0. And then we're going to go over here to 5. Alright, so this function, we kind of set out zones here. And we say what happens in between these zones. So let me erase this up here. We don't need this anymore. Alright, so we're just going to look here at these zones. So we pick a number less than negative 1/6, like negative 1. Alright, so if we put negative 1, we just want to decide, does this result in a negative or a positive number? So 15 minus 3 times negative 1 over 6 times negative 1 plus 1. And that works out to be that's 18 over negative 5. And we don't care really about this other than what is its sign. It's a negative number. So the function is down here. It's down here doing something that's curving or being a line. Whatever it's doing, it's down here. Alright, now left of 1/6, 0 is my favorite number between negative 1/6 and 5. So if you put in 0 over here, you really just get, you can see really quickly, you get 15 over 6, or sorry, over 1. Alright, when x is 0, that goes away and that goes away, so you just have 15 over 1. And that's a positive number, so therefore this function is positive here between negative 1/6 and 5. And you can continue to try numbers. If you want to try 4 or 3, whatever you want to try, they'll all give positive numbers, but I always pick 0 if I can. And then to the right of 5 would be a number like 6. Let's try, if we put 15 minus 3 times 6 over 6 times 6 plus 1, and we get 15 minus 18 is negative 3, and that's positive 37. But then again, the quantity of the number doesn't matter, it's the sign. So the sign of that number is negative. So any number you put in greater than 5 will be negative. So now the original function says, the original equation says, when is this less than or equal to 0? Alright, so it's less than or equal to 0 here, alright? Over anything over here less than negative 1/6, and anything greater than 5. So right, we say x, when x is less than negative 1/6, and when x is greater than 5, and sorry, we can't write it that way. We would say x less than negative 1/6, and when x is greater than 5. Now, keep in mind here, this question says less than or equal to. Alright, we can be equal to 5. Alright, 5 is what made the numerator 0, so we can be equal to here, but we can't be equal to negative 1/6 here. So we have to write this as negative infinity to negative 1/6 with a curvy brace, union, and then we can do square brace 5 to infinity. And that's the final answer. Look for a square brace there, but curvy here.